Welcome to the lecture video on linear variable displacement transducer. I am P. Satyapriya, working as an assistant professor in Department of Electrical and Electronics Engineering, K.S. Rangasamy College of Technology, Tiruchendur. Let us move on to the topic LVDT, linear variable displacement transducer. In general, transducer is a device which is used to convert one form of energy into another form. LVDT is one type of transducer which is used for measuring the displacement. Working principle of LVDT is mutual inductance, and the displacement, which is a non-electrical energy, is converted into an electrical energy. And the way how the energy is getting converted is described in the working of LVDT in detailed manner. Construction of LVDT. As shown in the figure, LVDT consists of a coil assembly and a core. The coil assembly is typically mounted to a stationary form, while the core is secured to an object whose position is being measured. The coil assembly consists of three wounded wires on a hollow foam. The core of a permeable material can slide freely through the center of the foam. The inner coil is the primary winding, which is excited by an AC source as shown in the figure. The magnetic flux produced by the primary is coupled to two secondary coils of the transducer. The number of turns in both secondary winding is equal, but they are opposite to each other. That is, if the left secondary winding is in clockwise direction, the right secondary winding will be in anti-clockwise direction. Hence, the net output voltage will be the difference in voltage between the two secondary coils. The secondary coil is represented as S1 and S2. The esteemed core is placed in the center of the foam, which can be moved in or forward motion as shown in the figure. The AC excitation voltage is 5 to 12 volt and the frequency of operation will be 50 to 400 Hz. Let us see the working of LVDT by splitting the cases into three based on core position inside the insulated foam. Case 1. On applying an external force, which is the displacement, if the core remains in null position itself without providing any moment, then the output voltage, the voltage induced in both secondary winding are equal, which results in the net output voltage is 0. That is, ESC1 and minus ESC2 is equal to 0. For case 2, when an external force is applied and if the iron core tends to move on the left side direction, then the EMF induced in the secondary coil 1 is greater than when compared to the EMF induced in the secondary coil 2. The resulting higher the voltage of secondary coil 1 in relation to the secondary coil 2, which causes the output voltage that is in phase with the primary voltage. Therefore, the net output voltage will be ESC1 minus ESC2. Let us see a small activity. You can write down your answers for the case 3. In case 3, when an external force is applied and if the steel core moves to the left side direction, what will happen to the output voltage and the phase difference between them? Now, you can pause the video and write down the answer and then you can resume. Hope you wrote the answers for the third case. Now, let's verify the answers. Case 3, when an external force is applied and if the steel core moves to the left hand directions of the core, what happen will be the question. The EMF induced in the secondary coil 2 is greater when compared to the EMF induced in the secondary coil 1. That is, the greater voltage on secondary coil 2 causes the output to be out of phase with the primary voltage. That is, the net output voltage will be ESE2 minus ESE1. When you compare the cases, case 2 and case 3, in case 2, the voltage of the secondary and the primary both are in phase. In case 3, the primary and the secondary voltage are out of phase. In this, ES2 minus ES1 is the net output voltage. Now, let's see the output voltage graph drawn between the output versus core displacement. A linear curve shows that output voltage varies linearly with the displacement of the core. Now, let's see the advantage of LVDT. Infinite resolution is present in LVDT. High output voltage can be obtained. LVDT gives high sensitivity, very good linearity, ruggedness. It can produce less frictions or the advantages of LVDT. Thank you, listeners. Thank you for watching the video.